Today I will be proving the electric potential for a dipole in a uniform electric field.
So in this slide you can see that there is a dipole having two charges, positive and negative, and kept in a uniform electric field on which two forces have been applied that are equal and opposite, and you can see the electric field diagram also. So let's begin with the further topic and in continuation with this lecture. Thank you.
Proof that PE for a dipole is given by the dot product of vector P and vector E, which can be written as PE cos theta, which we already studied in mathematics part. Also you can see a figure which I have drawn here already. You can see there is a uniform field in which the dipole is placed. Two charges, one negative and one positive, and they have couple of force, one in the direction of the electric field and one in the opposite direction of the electric field. It is the property of a dipole that the force exerted on the positive charge is always aligned to the direction of electric field, and the force exerted on the negative charge is always opposite to the electric field, and force on a charge is given by E dot Q, means electric field multiplied by the value of the charge. The distance between these two charges are 2a and they are aligned with the electric field at an angle of theta. So we can define that work done in moving the charge from one point to another point in an electric field is given by the potential energy of the dipole. Before proceeding towards the proof of potential energy, I would like to show a diagram. Here you can see that dipole is exactly parallel to the electric field or aligned with the electric field. This state is known as stable equilibrium. In this state the torque is 0. What is a torque? See, we can see that couple of forces are acting on the charge, and wherever there is a couple of force, we have studied in rotational mechanics that torque is generated, and that torque is given by cross product of the two vectors, vector P and vector E, and it is given by PE sin theta. This is due to the presence of couple of force on the dipole, and due to this torque the dipole rotates. So in the stable equilibrium state we can say that theta is 0. So putting theta here 0, we will be getting torque as 0 value, means there will be no movement with the dipole and it is a stable equilibrium. But listen carefully this point what I am telling you. Suppose we have left the dipole in a stable equilibrium, means just parallel to the electric field, then there will be no work done, and for doing a work or after moving a dipole we can experience a work done, and work done what we have already defined is the potential energy stored inside the dipole. Here also we have to do one thing, हमें एक काम करना है, जो सीधा डाइपोल रखा हुआ है उससे हमें थोड़ा सा रोटेट करके एक एंगल पे लेके आना है. इस रोटेशन करने के लिए हमें क्या चाहिए होगा, हमें थोड़ा वर्क डन करना पड़ेगा. इन सिंपल लैंग्वेज आई कैन गिव यू एन एग्जाम्पल. इफ यू पुश अ टेबल kept on the floor, you have to do a work done. In the same manner, we have to rotate this dipole from its equilibrium position to a unstable equilibrium position. So now we can define work done is actually turning from stable position to a unstable equilibrium is equal to the electric potential. Fine, I think you have understood this thing. This is very important concept. ये डाइपोल ऑलरेडी स्टेबल इक्विलिब्रियम में था, जब हम इसे थोड़ा सा रोटेट करेंगे तो ये अनस्टेबल इक्विलिब्रियम में आ जाएगा, क्योंकि रोटेट करते उसके ऊपर दो फोर्स एक्ट करने लगेंगे और वो ऐसे ऑसिलेशन करने लगेगा, ये डाइपोल ऑसिलेट करने लगेगा. सो उसमें इलेक्ट्रिक पोटेंशियल जनरेट हो जाएगा. दैट इज़ ओनली this is what we have defined here, that the work is done in turning from stable position to unstable equilibrium is equal to the electric potential. ये जो work done करना पड़ा है वही actually उस dipole के अंदर as a electric potential store हो गया है. Now we have to prove our equation. So let's prove the equation. How will you prove? In normal mechanics portion, we all know that work done is given by F dot x, means if force is applied on an object and it moves till a distance of x meter, then the work done, then there is said to be work done is on the object. But in rotational mechanics, we say this force is actually the torque, and this linear distance converts into a angular distance, therefore we use theta here. So now we can replace this small work done on that dipole by torque into d theta, and if we will integrate this small work done, it will finally give us the total work done on the dipole. So W is given by P E sin theta. We have already prove this, or we already know this, that torque is given by P E sin theta. So I am replacing tau with P E sin theta, and hence this P E sin theta we can integrate and we will be getting minus P E cos theta. How? P is constant, E is constant, E is already a uniform electric field, P is the dipole moment. So this is constant, and integration of sin theta is given by minus cos theta. Hence prove that work done on a dipole is electric potential stored in it, potential energy, and it is given by P E cos theta. Keeping it short, I am concluding this topic by taking three cases. If you put theta is equal to 0, means this condition, this is stable equilibrium condition, you will be getting u is equal to minus p. Put theta is equal to 0 here, cos 0 is 0. Second case is if you put theta is equal to 90 degree, the potential energy will become 0. If you put theta is equal to 180 degree, the potential energy will become positive P dot E. Now tell me one thing, which has the minimum potential, in which case you are getting the minimum potential? Obviously the negative one will be giving us the minimum potential. So when P is parallel to electric field, means dipole moment is parallel to the uniform electric field, we are getting the minimum potential, and this state is known as stable equilibrium condition. If the dipole is kept perpendicular to the uniform field, we are getting a unstable equilibrium, this is 0, and we are getting maximum potential energy if the dipole moment is opposite to the uniform electric field. I hope you must have understood. I can repeat the topic, and also I can clear the doubt. So you can comment in my comment boxes if you have any doubt. Please understand this topic. This is very important, dipole moment and expression for its potential energy, because in electrostatistics you will be countering so many proofs and so many concepts in future also, and the scoring part is very good with the point of view of boards. So thank you students, keep watching my channel and keep getting updated with the new concepts of physics and mathematics also. Thank you.